Say we are going to look at multiplying fractions, and there is area models that can help us understand how these numbers come to be when you're multiplying fractions. So that's our focus for today, is looking at the area models and even number lines. So first, what we will do is look at a number line, and really understanding what that multiplication symbol means is going to help us understand these parts and pieces. So when we look at 4 times 2/3, it means that we are doing 4 groups of 2/3. So if I have 4 groups of 2/3, I need to start with thirds. And if we're starting with thirds, we need to, number line needs to be cut into thirds. So we are going to have a 0 here, and let's start counting with thirds. So 1/3, 2/3, 3/3, and 3/3 is actually a whole. 4/3, so now we're getting into mixed numbers. 5/3, 6/3, go all the way to the end here. 7/3, 8/3, and 9/3. So if we're going to do 4 groups of 2/3, I'm going to get my color here to represent that. So if we're going to have 4 groups, we need to show these 4 sections of 2/3. So I can see my 1/3 and I go to 2/3 here. So this is my first group right here of 2/3. And to really show you the difference between, so we can see our 4 groups, I'm going to use another color. So we need another 2/3. Since I counted by thirds, I can then go, okay, here's my second group of 2/3. And then here's my third group of 2/3. And then my last one, my fourth group of 2/3. So 4 groups of 2/3, 2/3, 2/3, 2/3, 2/3, 4 times. So what does this end up getting us? 8/3. However, we cannot leave that answer because it's what kind of fraction? So if I have 8/3, that's my 10 here. If I have 8/3, what does that equal as a mixed number? So one way we can think about this is, mentally you can go, okay, how many 3's can go into 8? And really what you're doing here is division. 8 is being divided by 3. 3 can go into 8 2 times. So then I can have my whole number and my fraction left over. So it goes in 2 times, 2 left over out of 3. So our answer is 2 2/3. So this is starting with a whole and making groups of a fraction. It looks a little bit different if it's reversed. Now we know the commutative property that we can get the same answer no matter which fraction we start with. But the way it's demonstrated is different. So let's look at this one. If we had 2/3 times 4. So going back to what does that actually mean? It's we have 2/3 groups of 4. Multiplication means groups of. So anytime we're thinking about that, what's actually happening here, we're making groups of that 4. Okay? So on our number line, it's different. So we need to show that we have 4. So let's number this. 0, right? Now, the cuts in between are already there for us. So we are going to look at this as if the thirds are already there. So I'm going to skip 2, go to 1, skip 2, 2 wholes, and then I'm going to skip 2 and go to 3. So here are my 4 wholes. So what I've already done for you is made 2/3 of 4 Okay. So I have in every single hole, there's a 1/3, 2/3, 3/3. See how it's cut into 3 pieces? Be careful, don't count the cut, count the pieces. So 1, 2, 3, every single hole has 1, 2, 3, 1, 2, 3, 1, 2. Oh, my 4 needs to go over here. Otherwise, that would be cut into fourths. So we would have our 4 holes right here. So an extra tally we don't need here. Then what we are going to do is show these 2/3 of each hole. So this shading on the number line is a little bit different, where I'm going to go to 2/3, okay? 2/3 of each hole. 2/3, 2/3, and 2/3, right? So 2/3 groups of 4. Then we just have to count these up. Now, this is a little bit different than our last one. Our last one was nice. It ended right on our value of what we were going to end up getting. This one, we still have to think about putting it together. So when we think about that aspect of what is our answer, each of these is a third, right? So, or even you could say a 2/3. So we could add all of these together, them being the same denominator, we can do that, right? So 2/3, 2/3, 2/3, 2/3, add those together, what do we get? So I'm just demonstrating here that we have a third for every single spot here, and how many do we have? So we have 8 of them, right? 2, 4, 6, 8. That's still, of course, going to be 8/3 then. And we know with our improper fractions, we need to make them into mixed numbers. So this is going to be 2 and 2/3. Of course, it's the same answer because of that commutative property, that it doesn't matter which one we multiply first. But the important thing is seeing it on that number line and how different that is. Okay. So now let's look at one that's already done for us. What expression would this show? The trick here is look at what's represented on the number line first. So there's going to be 2 values on that number line. So if we go back here, we can see we had 4 holes and it was cut into thirds. We had thirds and it was cut into, or shown as into 4. So our number line is going to show 2 different values here based on what's numbered and then how the numbers are cut. So if we look at this one, it's starting with a 2 holes. And then what's happening to these holes? They're being cut into, let's see here, 1, 2, 3, 4 fifths. How many fifths is it representing? So 3 of them, right? So we have 3/5 twice. And our answer would be, well, we'd have to add them up. So again, there's 2 ways. I'm going to show the other way this time. This is a fifth, a fifth, a fifth, a fifth, a fifth, a fifth. I could add all those up. But what we know about adding fractions is if I take that 3/5 and that 3/5 and add them together, we can add the numerator, keep the denominator the same. So that would be 6/5. Improper again now. So how do I make this a mixed number? 5 can go into 6 once. There would be 1 left over. Still talking about fifths. So our answer being 1 and 1/5. Okay. So number lines showing the different number you're starting with and what it's being broken up by. Okay. Now, another way to look at these fractions being multiplied is looking at an area model. An area model can show you the 2 fractions and taking something of something, right? So if I have half of 3, it means half groups, oops, that's a third, half groups of 3, right? So how am I going to show this? Well, just like number lines, you're going to first demonstrate what you're starting with. So I'm going to draw a box. so I can show my half. Okay? Two colors are going to be really handy here. So if you have colored pencil or crayons, you're going to want two colors. I'm going to do all my drawing with my pencil, and then the colors I'm going to show with shading. Okay? So this box represents a whole. If I'm going to have half groups of three, I need to start with three. Notice we're always starting with that second number if I go backwards. So starting with the 2, starting with the 4, starting with the 3rd. So that second number we're always demonstrating first. So I'm going to have 3 holes. And because I'm going to have 3 holes, I want to make my box a little bit smaller. So 3 holes, because that's in our problem. And then what are we doing to these through 3 holes? We're making half of 3, right? So my 3 holes are already there. I don't need to shade anything with that. So I'm going to take and I'm going to cut each of my 3 into halves, right? Now I have 1 out of 2 for each of these. So I'm going to shade our halves to represent half of 3. So there's a half of 3. I had 3. I did 1/2 of each. What does this equal? So again, we can take our knowledge about adding fractions and go, okay, well, this is 1/2, right? And I have another half and another half and another half. If I add those up, I have 3/2. Improper again. Oh, this keeps coming back to us. We need to know improper fractions to mix numbers. So 1 whole, because we can make a 2 out of 2, and then there would be 1 left over out of a half. Okay. And you can kind of see that if you were to rearrange it and go, okay, I have a whole and then 1 left over there to make that 1. Again, if I rearrange, which one comes first? My answer should be the same. My product should be the same. So this time I'm going to do 3 means 3 groups of a half. So 3 groups of a half. That means I need to start with a half and make it into 3 groups. So if I have a half, right, I'm going to need to have a whole in order to make that half. Okay, so I need 3 groups of half. So here's a half, right? Here's a half. I need another whole to make another half. Do I have 3 halves here? Yeah. So I can show it like this. I have 1, 2 halves, and then my third half's right here. This one, I like this one. It's my favorite because the answer's there. It's just obvious. You don't have to recalculate anything together. Of course, those numbers are pretty small, so it's not complicated necessarily. But you can see I have 1 whole and a half. So really kind of bypassing that improper fraction. So see, I did not start with 3 wholes. I just started with the half to make 3 groups of them. Okay, so it always depends on what is being multiplied here. So let's take a second to analyze what if it was a fraction times a fraction. So we've only worked with whole numbers so far, and we can just demonstrate this with fractions. So columns go up and down, rows go side to side. We are going to show the 2 fractions coming together. So with the column, let's do 3/4. So that means on our image, we're starting with just 3/4. And fourths columns, okay, so I gotta cutting with my pencil here. I have fourths. Okay, now let's take one of our colors and let's shade in our 3/4. There's 1. My little extra dots go crazy here with my knuckles touching the screen. 1, 2, 3 out of 4. Okay. So this image right here is this fraction, right? And then what we're going to have is our other fraction demonstrated in rows. So that would be our 2/3. Here's what we're calculating. So now what gets a little discombobulated at first until you see what you're recognizing is we're putting this fraction on top of this fraction. And this is where the other colors are going to be handy. So I'm going to now cut this as if into thirds. So I'm ignoring these fourths and now I'm cutting into thirds just by looking at the rows. So do you see 1, 2, 3, right? And then I'm going to demonstrate my 2 out of 3 for my 2/3. So I'm going to have 1, 2, right? Again, 2/3. Now what this shows us is that if 2/3 of, or 3/4 of 2/3, this overlap here shows the parts of the parts. And that means we get the area. Now, because it's an area model, we have our rows and our columns have our total amount of text. So our overlap is, you see 1, and I'll make a dot here so you can see what I'm counting. That we have 1, 2, 3, 4, 5, 6 of them. This overlap tells us our numerator. Now, because we have our total amount of text, our area model, we need to use that for our denominator. What makes a whole here? So it's a 3 by 4, so it's a 12. Okay. So we take and we do one of the fractions as columns, one of the fractions as rows, and then the overlap is telling us what is our numerator, and then denominator is how many pieces total. So these extra pieces that just have the P and these extra pieces that just have the purple, those are not a part of the part, right? So you don't have those at all. Let's try another one. This time I already have it shaded for you. Now we use this shading because we don't live in a world on paper where it's always color. So you can kind of see where if I look at just my rows, what am I working with? If I look at just my columns, what fraction am I showing? If you just count the individual boxes, you're looking at just the answer. So if I want to know what the equation is, we need to isolate those thoughts. So we have our columns, there's fourths, right? And you see our rows, there's thirds. So then when let's look at the shading of just the columns. So how many are shaded down? Do you see just the 1 is? And then for our thirds, it's just 2. See, that one's not shaded. So this is shaded here because that's from the fourth. So we have 2/3. Now again, overlap for our answer. What's our numerator? What's our denominator? Numerator would be 2 for the overlap. Our denominator is how many pieces total, and that would be 12. So there are 12 total pieces. Now, when we look at an area model, we can also have a bunch of different options of what fraction you can actually show. So I have started here, a half. Is it the columns or is it the rows that show the half? It would be the columns. You have so I could have a half times what? So now look at the rows. The rows are in thirds. So all of these are possible thirds. So a half times, well, it could be 1/3, it could be 2/3. It could even be 3/3, which is also a whole. So looking at the boxes not shaded, we can figure out what expressions are actually could be shown based on those column cuts and the row cuts. Okay. So now let's try doing some area models ourselves. So I'm going to start with my pencil, and I'm going to have 3/5 of a third. So a fraction by a fraction means I'm going to start with a whole, so I can represent my fifths. I'll do my columns as my fifths. 1, 2, 3, 4, 5. Okay, so there's my fifths. Do not do all your cuts at once. Shade so you can see your first fraction. So now here is my 3/5. Can you see the yellow? Yep. 3/5. Then I can show my thirds. Now remember, that's going the other way. So I need to cut this into thirds. There's my thirds now. My rows showing that. And now I'm going to demonstrate 1/3. So I even find it helpful sometimes to write on the side. Okay, there's my 1/3, and then here was my my 3/5. 3/5, not 2/5, 3/5. So I can see those two sections. Now the overlap again is the numerator, so we should have a 3 in denominator. How many total pieces? And you can just count using your area knowledge. 3 by 5 is 15. Okay? So maybe pause and try this one. So the similarities are going to be there as far as how do we set it up, doing columns, doing rows, how do I get my numerator, what's my denominator shown in the area model. So maybe try this one and then let's compare and see how you did. So that would be time to pause. Okay, let's see how you did. So you had, now you can show any fraction in the columns or rows. It doesn't matter which one you do for which. It would just be like yours is kind of turned compared to mine. So I'm going to do fifths again this way. 3, 4, 1, 2, 3, 4, 5. Okay, so I have my fifths. And then I'm going to shade in my 1/5. There's my 1/5. Okay. And then I'm going to show my this one is. So if I'm gonna have hacks, right? This would, and I need 3 of them. Well, here's one. Here's 2/2. I need another one. In this case, you're gonna need another whole to show that third half, right? So the thing that we need to remember in this case here is that if I'm gonna have that third half, go back to my highlighter. If I'm gonna have my third half, it still needs to be of the 1/5. I don't have the 1/5. So I have to extend that and continue the 1/5, which means all of those, and then shading that one. So whenever you see an improper fraction, you're going to need to continue it. Otherwise, you're not seeing that total overlap. So if you look and see our overlap, we have 1, 2, 3 out of what makes a whole. Be careful. What makes a whole? We have 2 wholes, so we're not putting them together. What makes 1 whole? So it would be still a 10. Okay? Not an improper fraction. But if we wouldn't have had this extra piece to show that 3/3 or 3/2, then we wouldn't have seen our total. Okay. So now you are going to continue practicing with a heavy focus on if I already have a cut for you, can you change different amounts? And if you are on edge elastic, you can use scratch pad, but you could also, when you get to the questions, put in the answers for edge elastic and then just recreate this on a paper or even print this from Canvas. Okay, so we're going to look at area models. We're going to look at all the different expressions that can be shown with this area model based on its cuts. We'll try out number lines. I already have them started for you. And whether it's a fraction or a whole number. And then we'll continue on with our work tomorrow and moving past area models and how can we just calculate these no matter what fraction we get without using the models. Okay, good luck.